Welcome back to another video. It's Dr. Tarcia Hubert here, and in this video we are going to be talking about the graph of the sine and cosine functions, okay? So just to get us started, the sine and the cosine functions are what we call periodic functions. That means that they repeat the same repeat the same performance over and over and over and over again. And so you'll see in a little bit, it just means that they're going to do something for a certain amount of time. And then once it reach a certain point, it's just going to repeat what it did previously. And it's going to keep doing that over and over again. And so the sine and cosine functions are periodic functions. So to get us started, we're going to first start just by using our unit circle, because we're going to use our unit circle to get the sine and cosine values. We're going to start with the sine function. And so remember that sine is all of your y values and cosine is all of your x values. Another thing is that notice that our unit circle, it has a circumference of 2 pi. So once you get back around, so you start here at 0, but when you come back around to 0, you hit 2 pi. And so, but if you keep going with another rotation, then you get bigger than 2 pi. Or if you go in the opposite direction, you get smaller than 0. You go on the negative values. And so two things. First of all, we use the radian values, not the degrees, when we graph. So we'll be using the radian values when we graph for our x values. And then the sine or the cosine, these values is what we'll get out in our function, our x or our y values, depending on which function we're graphing. And so to start off, I was going to say, once you get to 2 pi, then you start all over again. So as you get bigger than 2 pi, you start all over again. And so that's where our period starts to change or shift, where we start to repeat what we did before. All right, so for the sine function, we're going to start off by graphing the sine function. So y equal to sine of x. This is what we're graphing first. Oh, not sure what happened there, but that's supposed to say sine of x. And so we want to know, and I just picked some values. I picked all the quadrantal angles. So remember, those are the ones on the x and y axis. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. But I also picked an angle in between each of those so y'all can see what's happening in between each quadrantal angle, okay? So I just picked the one, it looks like it's directly in the middle, but it's not directly in the middle, but pi over 4, 3 pi over 4. So if I go back to the unit circle, see pi over 4 is here, 3 pi over 4 is here, 5 pi over 4 is here, and 7 pi over 4 is here. And you know what? I think it is directly in the middle. I made an error because pi over 2 is 1.57 if you divide that by 2. So it's not exactly in the middle. Pi over 4. Oh, yeah, it is in the middle. Okay. Sorry, I'm getting confused. I'm thinking about the value that you get out. But anywho, pi over 4 is directly in the middle of 0 and pi over 2. And 3 pi over 4 is directly in the middle of pi over 2 and pi and so forth. So I chose those values that were directly in the middle. All right, so I'm doing the sine function first. So I'm going with the y value. So the y value of pi over 4 is square root of 2 over 2. The y value of pi over 2 is 1. The y value of 3 pi over 4 is negative square root of 2 over 2. The y value of pi is negative 1. And so I want to put those values in my chart. So the sine of 0 is 0. The sine of pi over 4 is square root of 2 over 2. The sine of pi over 2 is 1. The sine of 3 pi over 4 is square root of 2 over 2. Sine of pi is negative 1. I mean, no, not negative 1, 0. Sine of 5 pi over 4 is negative square root of 2 over 2. Sine of 3 pi over 2 is negative 1. Sine of 7 pi over 2 is 7 pi over 4 is negative square root of 2 over 2. And the sine of 2 pi is 0. And so that gives us our x and our y values. And again, those values came off of our unit circle. For each of those angles, you look at the y value in order to get the sine. And so now I'm going to plot those. So starting with 0, I have a point at 0. And then out here, I only have the quadrantal angles. So I'm going to go ahead and plot the quadrantal angles first. So at pi over 2 is at 1. At pi, you're at 0. At 3 pi over 2, you're at -1. At 2 pi, you're at 0. And I put so you can kind of see what's going on, but I put the values in between each of those just so you can be for certain what's going on in between those quadrantal angles. So at pi over 4 is square root of 2 over 2. If you plug in square root of 2 over 2 in your calculator, square root of 2 divided by 2, you get 0.707. So that's approximately 0.707, which is almost at 1, but not quite at 1. So pi over 4, remember, is between 0 and pi over 2. So at that, we're like at 0.7. And then at 3 pi over 4, we're at that same value, 0.7. At 5 pi over 4, which is between pi and 3 pi over 2, we're at negative pi square root of 2 over 2, which is negative 0.707. I don't know why this thing keeps popping up. And then at 7 pi over 4, you're at that same value. And so look, your graph ends up doing this. This. And if we were to keep going, it would continue that pattern over and over again. And so it looks like a wave, basically. And it just keeps waving and waving and waving. And I'll show y'all a full graph in a minute. But this is what we call the graph of sine over one period, okay? And this is one period from 0 to 2 pi. That's because your circle starts to repeat itself after that. If you keep going bigger than 2 pi, you're going back to the same values you had before. All righty? And so some basic observations from the graph of sine x is, first of all, the domain is negative infinity to infinity. The domain, remember, is all of your x values. That means that you can plug in any x value and get a y value out for this graph. Your graph keeps going and going and going like the Energizer Bunny. But the range is different. The range represents your y values. And if you notice, the smallest y value here is over here at -1. And the biggest y value, which is here at 1. So your range is -1 to 1, okay? And this is the graph of y equals sine of x. Let me adjust this so y'all can see what that says up there. Y equals sine of x. Yeah, there we go. All righty. And the x-intercept. So where does this graph cross the x-axis? Notice it crosses here at 0. It crosses at pi. It crosses at 2 pi. And it's going to continue that pattern. If you guess where it's going to cross again, hopefully you guessed 3 pi. That's correct. It'll cross at 3 pi. It'll cross again at 4 pi. It'll cross again at 5 pi, and so forth. So what we say is that the x-intercepts happen at every pi n or n pi. It doesn't matter which order you write it in, but basically that's saying every integer of pi, every integer times pi. So n is an integer, so every 1 pi, 2 pi, 3 pi, 4 pi, and also the negatives, -1 pi, -2 pi, -3 pi, and so forth, all right? Also, this graph has a period of 2 pi, so from 0 to 2 pi is where it completes one rotation. If you go further, again, as I mentioned earlier, it's just going to keep repeating what happens. So 0 to 2 pi is the period of which it does something unique before it starts to repeat the same thing again. And then this graph is what we call symmetric to the origin. Now, it's kind of hard to explain on the computer, but just imagine taking this graph and shifting it 2 times in a clockwise direction. If I picked up this graph and I shifted it 2 quadrants, basically, in a clockwise direction, if that graph is is a part of my graph, once I shift it twice, then we say that's symmetric to the origin. So basically it's saying that this graph is going to keep going like this and repeat that pattern over and over and over. Because it's symmetric to the origin, it's considered an odd function. And an odd function means whenever I evaluate something that's negative, that's the same as saying take the negative of that function, of that thing evaluated as something positive. Alrighty, hopefully that makes sense. Okay, and so these are some properties of the sine function. Now let's look at the cosine function. So we're going to do the same thing with the cosine function, except this time we're going to look at the x value. So look at all your x values. So at 0, you have 1. At power 4, you have square root of 2 over 2. At power 2, you have 0, and so forth. And so for y equal cosine of x, we're going to get 1 for 0. We get square root of 2 over 2 again for power 4. We get 0 for power 2. We get square root of 2 over 2 again for 3 power 4. At pi, we have -1. At 5 power 4, we have negative square root of 2 over 2. Oh, also 3 power 4 is negative, my bad, because that is the x value, and in the second quadrant, the x is negative. At 3 power over 2, we get 0. 7 power 4, we get a positive square root of 2 over 2. And at 2 pi, we're back at 1. And so if you plot those points at 0, you're at 1. Pi over 2, you're at 0. At pi, you're at -1. 3 pi over 2, you're at 0. And, what did I just do? Okay, sorry, I just did something completely crazy to my screen. So we're going to pick up here at 3 pi over 2, we have the point 0. And then at 2 pi, we have 1. And again, you can plot those points in between. Pi over 4 is in between 0 and pi over 2. And you have like 0.707. And 3 pi over 4 is between pi over 2 and pi. You have negative 0.707. I just included those so you can actually see that it's following this path here. Oh, I'm completely off. Okay. So it does the same type of curve as sine, but a little bit different. Now it's different because if we go back to the sine function, my computer just don't want to act right today. If we go back to the sine function, you see it started at 0 at the origin. But if we go back to the cosine function, and again, this is y equal cosine of x. I don't know what's going on, this weird stuff. Okay, so if you go back to this one, you see it starts here at 1. And so it does the same type of motion, it's just moving a little bit differently. And so we also notice about this function. So here's the more accurate graph of it. It's not sketched like mine. But we notice about this function that the domain is still all real numbers. The range is still -1 to 1. But this time it crosses the x-axis. You see at pi over 2, 3 pi over 2. If you can guess where it's going to cross next, it's going to be at 5 pi over 2, then 7 pi over 2, then 9 pi over 2. It's every odd integer times pi over 2. Alrighty, so we represent an odd number with 2n plus 1. 2n plus 1 here, that represents an odd number. Alrighty, so every odd integer times pi over 2. That is where it will cross the x-axis. Also, it has the same period as the sine function, which is 2 pi. So it goes from here and it comes back to that spot at 2 pi. And so now it's going to start to repeat that same motion. Now this graph is symmetric with respect to the y-axis, meaning if you folded it at the y-axis, both sides will lay directly on top of each other. That means it's an even function, which means when you plug in, so I'm down here, when you plug in or when you take the cosine of a negative value, that's equal to the cosine of that value positive, okay? And so that is the cosine function. And let's see if I could show you all really quickly what this looked like on the graphing calculator. So I'm at desmos.com/calculator. You can see the website up here, and it's an online graphing calculator. And if I type in sine of x, you can see it shows me the graph of sine of x. And then if I hover over these points, it tells me the points. This is 0, 0. This is pi over 2, 1. This is pi 0. So it gives me the main quadrantal points. As you notice, it doesn't give me the ones in between, but it shows me the quadrantal angles. Alrighty, and then I could also plug in cosine of x, and that's the blue graph. So you can see they're exactly the same, except one of them is shifted over some. So if I was to take this sine, which is in red, and shift it to the left, you will see that it's the same as the cosine, okay? So that's how you can see the graph on the graphing calculator. Now, if you haven't already, go ahead and subscribe to my channel. Hit that subscribe button. If you have any questions, put them in the comments below. And if not, I'll see y'all in the next video where we'll talk more about the graphs of the sine and cosine functions.